Welcome back. We're still looking at some equations of tangents and norms. However, when it comes to tangents and norms, it doesn't always particularly tell you what you need to do in those words. Sometimes when it comes to the questions, you need to be able to use specific words in the question to help you work out what it's asking you to find. So for instance, in this question here, it's saying, find the equation of any horizontal tangents to this equation. Well, if we look at this here, the key word is horizontal. So we know that because we're trying to find tangents, we've got to find the gradient function. And we've got to find out what is the gradient of any horizontal lines. So for instance, if I drew a horizontal line here, I know that this here has a gradient of 0. Because anything that is going through y equals in terms of a horizontal line, we know from our derivative laws that y is equal to c. The derivative of that constant that goes through y is equal in a straight line. A horizontal straight line is equal to 0. So therefore we know that this equation, when I differentiate it, has to have a gradient of 0. Another thing that we look in here is, it's got that word s in there, okay? So that indicates to me that there could be more than one tangent that's horizontal. And if you think about it, when we look at this type of equation here, this polynomial, it's a cubic. And a cubic, if we look at it, essentially in 2 points, is going to have that horizontal tangent, where the gradient is going to be 0. Okay, so our stationary points, our maximum and minimum. So we know straight away that there should be 2 of these occurring, because we have 2 curves that have a maximum and minimum in terms of a, not a standard cubic, but in this type of cubic here. So let's start working through this question. The first thing we do is, before we can find any tangents, we have to differentiate. There's no use me finding x or y's in this one here, because I'm not being asked to find what that tangent line is at a particular x. I'm just being asked to find what are the equations that would go through that point when I have an x gradient, when I have a gradient of 0. So the first thing we do here is let's differentiate this function. So we get dy on dx is equal to 6x squared plus 6x minus 12. So this here is the derivative, and we know that to find a tangent, or find the equation of it, we have to actually know what we've got to equate this to. So it's saying we need to find any equations with horizontal tangents. So that means I have to make this equal to 0. So I can write this down here and say, well, 6x squared plus 6x minus 12, well, it must equal 0, because I'm going to have a gradient of 0. Well, I can solve this using your graphics calculator, but we can solve it using algebra, which we're going to do right now. Well, my first step I can do here is I could factorise my 6 out. So if I factorise 6 out, I'll get x squared plus x minus 2 is now equal to 0. Now, because I've factorised this out, I'm now in a better opportunity to be able to find out what those 2 values for x are going to be. And we can use the null factor law for this. So we can ask ourselves, well, what 2 numbers multiply to give me negative 2, but when I add them, I get 1. So I know that I'm going to get 2 numbers here. And they have to equal to 0. What 2 numbers in this equation can I multiply to give me negative 2 and positive 1? Well, I can get positive 2 and negative 1. And we can double check this. 2 times negative 1 does indeed give me negative 2. 2 take away 1 does indeed give me positive 1. So therefore these are the correct factors I'm looking for. So therefore x has to equal -2 or x has to equal 1. So I found out my x coordinates, but that's not going to help me because if I have a horizontal tangent, I'm not going through the x-axis unless I'm going through 0. I'm going through a different number. So if I have my x values, I'm going to substitute these into this equation to find out what the equivalent y value is going to be. So when x is equal to -2, we have 2 -2 cubed plus 3 times -2 squared minus 12 to -2 plus 1. Now if we work all these out, we should get what? -16 plus 12? Can you see it? Yeah, plus 12 plus 24 plus 1, which then gives me something along the lines of 21. Do I get 21 for that one? Should get 21. So therefore, we get -2 and 21 at our first point. Well, when x is equal to 1, we get 2 times 1 to the cubed plus 3 times 1 to the squared minus 12 times 1 plus 1. Well, if we look at this here, we get 2 times 1 equals 2, plus 3 equals 5, plus 1 equals 6, minus 12 equals -6. So therefore, we get 1 and -6. So, we've now got our possible answers. So therefore, we can say that the horizontal tangents are going to be y is equal to 21 or y is equal to -6, which, if we were drawing that graph again, will kind of make sense because we've got a line coming through here and a line coming through there. There are your two horizontal tangents. So we've got one at 21 and one at -6. So this question is an example of, it's not always going to be a straightforward question. Okay, it's going on the idea that you understand that if I'm finding the tangent, I've got to differentiate, but I'm finding horizontal tangents. So therefore, I'm looking for something where I'm going to have y is equal to something. So still getting to this point here is not going to help me. That's just giving me the x equivalent where it's going to be a horizontal tangent. Alright, see you in that next video.